This is, of course, a big topic, so this will just be a brief introduction. Where are we going today? First, I'll talk about choosing a graph type, a couple common options, and generally when you might want to use them. And then also we'll go through a visualization example, just a couple quick tricks to get your message across more clearly. So starting with common graphs and when to use them. First, we have bar charts. So bar charts answer the question of how many are there, and this is based on categorical variables. So you can see in this chart here, we have a department names on the left and the status of performance reviews on the top, and the number in each category here. And if we graph this, that looks something like this. So we see our departments, and then we see how many of each performance review status have been completed. We can also consider the rows and columns. So this is the same information, but graphed the other way around, where the status of performance reviews is on the x-axis, and then we have the height of the bar showing the departments that are in each category. Another thing we have are distributions. So we can use box plots and also histograms, and these use continuous variables, but they can include categorical variables. So you see here, we have data on sales and with marketing, and we have the number of performance reviews submitted, or actually the scores rather, on the right-hand column. So if we have a categorical variable for a histogram, that would either need to be grouped. So in this case, we're doing the whole sales and marketing function in one, but you could also do multiple histograms next to each other. Or for a box plot, it's easier to put those next to each other and start to see the way the distributions look together. And just a note, not to be confused with bar graphs. So a histogram maybe looks similar, but this is for continuous information, whereas these are for discrete categorical information. So then we have line graphs. These are usually to look at a change in information, but usually over time. So here we've got our original categorical data and the original chart that goes along with that. And if you're using a program like Excel, as I was, you can actually just put this into a line graph instead. And you can see, for example, this yellow bar, this line is following the same line of these bars, but this doesn't really help us see anything more clearly. It's not clear why we would use lines for this information in this way. But if we were instead to have the information over time, so review status over time, so how many are submitted over time, how many are ineligible and incomplete, we start to see a little more of a picture here. And we could also do the same for reviews over time by group, so how many are submitted for each group. And of course, in this case, this is the graph changes, so you have to have the dates on one side of your chart. So again, this is made up data, and I'm able to play around with what it looks like for the purposes of this demonstration, but you would want to consider, do I have categorical data, or do I have it over time? Next, we'll talk briefly about scatter plots. This is the relationship between continuous data variables. So in this case, we've got 2020 performance data and 2021 performance data. So do they relate? And you can see in this case, they relate quite a bit. And finally, pie charts. My note here is usually it's better to use a bar graph. You can see the same data here submitted by department. And, you know, that's fine. We have a little bit of a picture of what's going on here, but it's actually hard for the brain to really parse out pieces of a circle. It's just not that easy. And if we put that same information back in our original bar graph, it's actually easier to tell, okay, sales and IT have the exact same number, and how much less is marketing and how much more are executives. It's a lot easier to tell on our bar graph. So unless you have a really good example, stay away from pie charts. So with that, we'll move into a visualization example. And as I've been using, made up performance data, so we'll just stick with that. We're going to look at performance data by group over time. So here we have a table in APA format, and I put it this way because we're used to seeing information this way in academia, it is a good way to have a standardized format for information. It looks clean, and it's a great way in a scientific community for us to present information in a way that is relatively unbiased. This data is not telling the reader what to see, it's just giving the information in a very structured format. And it's up to the viewer to sort of look at this descriptive information and parse out the information based on what you've written, and maybe come to their own conclusions too. So when we are in a business context, we often want to visualize. We want actually our business leader not to have to do that much work when they look at the data to be able to tell what you're talking about. And so we usually want to graph, which is what we just talked about. So in this case, we have information over time, you can see here. So we're going to start with a bar graph, a line graph. Let's go back. So we're going to go into line graph, but my title here, Good Visualization Goes Beyond Graphing. Just taking this exact information and sticking it into a line graph, we actually, yes, we can see trends that we couldn't have parsed out just by looking at this chart. But actually, this still takes a lot of effort for the viewer to understand what is interesting to look at here. Why am I looking at this chart? We still have a very descriptive title. We have all these crazy colors going on, and it's actually not clear. What am I supposed to take away? So our steps to storytelling with data, getting a message really across in an image based on your data. These are not the only steps. You could do more, but I think the key, easiest baseline steps are to, use graphs to first explore your data and understand what is it that I do want the viewer to take away. And then once you've done that, highlight that information, add an active title, and then generally for the visual, reduce clutter and use color and proximity to label. So we'll go through each of those steps now. So understand and highlight the takeaways. Here's our original graph, and we can look at it and start to see a few things. So things I notice are that these two lines go really high, these two lines go really low, and then these ones are all grouping here. So I could be interested in any of those things. Here's an example where I get interested in the highs and the lows. Of course, I could have just been interested in the groups that are rising, could have just been interested in the groups that are falling, or I could even be interested in this middle line, the overall trend. I could be like, wow, if I were to actually add an overall trend, it would be pretty flat in there. And maybe that's the thing I want to highlight, that there is no change in the overall trend, despite these crazy looking bumps. So once I've highlighted my takeaways, what I want the viewer to actually see when they just glance at the graph, I should actually add an active title to go with it. So this one is very descriptive. The % of performance reviews submitted for each business group across 4 fiscal years. Yes, that's what's happening here. But it doesn't tell me what the message is. Instead, I could say something like % of performance reviews submitted soars in some groups and plummets in others. Yes, it's a little bit like a newspaper headline. But the point of that is that now I have both the text and the colors, and they are telling me as the viewer what is interesting about this graph. Here's the same example in a different example. Average % performance reviews submitted returns to 2017-2018 levels. So I see now, I read that, and then I look at this graph and I'm like, you're right. It has come down to the same as it was before. And of course, I could do many other versions of this graph. There could be other things that interest me. I could, instead of having this overall line be the way it is, I could have it be an average across the years, a flat line, and change my title accordingly. So it's really up to you as the analyst to do that exploration, understand what you want the viewer to take away, and then design your graph to actually relay that message. Once we've done that, we want to just reduce or improve the visualization a bit from a just like purely graphical visual perspective. So reducing visual clutter is a great way to do that. When we look at a graph, what does not need to be there is a great question to ask ourselves. So one thing I see for sure are all of these decimal points